All right, everybody, we're back with part 6 of the final project for the Stellar Robotics 2018 CAD class. This is probably going to be the last video. We're going to lighten the drive rails. We just have these two, and then the mirror images over here will update automatically. At this time, I'm not going to create a video for adding all the fasteners to this. Maybe at the end of this video, if it's not super long, we'll talk about what the fasteners would be. But I mean, I've addressed how to do that in previous videos. Plus, during the season, we would not add the fasteners to this unless we had the time and wanted to make our model more accurate. What we'll probably do this coming season is finish the modeling, get our fabrication people working so that we can get stuff fabricated, and then if the CAD people don't have other tasks to do, which is unlikely, but if they don't, we'll have people work on putting fasteners in just for the sake of the accuracy of the model in terms of weight, and we can put it in our engineering notebook and everything. All right, so let's start at the outside drive rail and work our way to the inside. We're going to basically do the same exact process we did on the gearbox plates, just to add that same kind of a pattern. We've got to be a little bit careful because this is very, very important structural component. We also can't take out too much material too close to the bend, otherwise weird stuff happens when you bend it. It kind of torques the flange and it pretty much just destroys the geometry of the part. So this is kind of what limits taking weight out of these parts. So let's create a sketch on this inside face here. Now let's project. We got to project some things. So let's project the outsides of all these flanges. Has to be the outsides. Am I getting those? Yeah. Outsides of all the flanges. Let's project the holes. Yeah. All right. So to start. All right, so there's a few different ways we could do this. I think what we're going to do is we definitely want a vertical web above each wheel. That's just to transfer the weight of the robot to the flange and everything, and to transfer the weight. If we have any mechanisms mounted to this flange, we want to transfer their weight to the wheels, rather than through the rest of the structure. In addition to that, we're going to want angled webs coming from the wheels to connect. I think we're going to put like a vertical web here in between the wheels, and then we're going to do kind of a truss up and then back down. I think we could do a square around these for mounting these, but I think we're just going to do a circle. I think it'll look nicer, and I think it'll create less stress risers because we don't have any actual corners between. Well, I guess the angles of the corners will be larger. I'll kind of, once we get some geometry in here to look at, I'll kind of explain that a little bit better. All right, so basically, we're going to do a web from the center up to this corner. We're just going to aim it at this corner and get it as close as we can. We'll have a vertical web here, vertical web in the middle for all this, and then just kind of a truss. So let's start working here. So let's knowing where to start on this is a bit difficult. So we know we're going to have a web that goes up here. So let's create an arc like that, and then we'll go from here over and then like that. All right, and actually we're gonna do. I didn't mention this. We're gonna do half, and then we'll mirror to this half because it'll be the same. You won't always be able to do that if you have some other components in here that make the drivetrain asymmetrical front to back. But in this particular case, the drivetrain's symmetrical front to back, so we can do that. So you got to be careful when you make that assumption, because you can start the season with your you can start the design process with your drivetrain being symmetrical front and back, and then you get through and you have to mount some mechanism really weird, and you add holes, and that goes away very quickly. That was kind of how our 2016 drivetrain ended up being, because the drivetrain itself, as a standalone mechanism, was symmetrical front to back. However, as soon as we mount the gearboxes for the drivetrain, that they were mounted in the back, and then we had a climber attached to the back, and it was all kind of integrated into the drivetrain. So it was just you know, after we designed the frame and then started moving on to their stuff, it quickly became asymmetrical. Alrighty, so let's, well, I want to know where this corner is, so let's create a point, and let's, remember we projected these lines, you can kind of see them if I hover over them, but they're hidden by this flange being in the way. But the dotted lines are there, you just can't see them very easily. So if I do a coincident constraint from that line to there, and that line to that point, this point will now be in the corner. So then, in addition to that, we're going to have an arc here, and we're going to have a web, and then down, and then to make the bottom. We're not going to do a web kind of to this corner because the angle would be so shallow, it would just end up filling this in. And I don't really think that buys us anything. Alright, so let's create an arc. Then we'll switch to the line tool, do a line up, down, and back. We want this line to be horizontal, so we'll set that to horizontal. We want these two arcs to be equal in radius, so we'll set the radius to equal. Then we want these two lines to be parallel. Alright, so let's start throwing some important dimensions in here. First of all, this has to be ½ an inch away, right? At all times, we have to be ½ an inch away from the outside flange, which puts us, you know, about ¼ of an inch away from the inside of the bend radius. That's very important. That's just a fabrication constraint. That's the way it has to be because of the way we're bending this. So from here to there will be ½ an inch. Same thing on the sides, and the same thing on the bottom. Now we need to pick a radius for this. Start with 1 inch. We know our bearing blocks. We want to support the full face of our bearing blocks, and we know those are 1.5 by 1.5. So we don't want to have any weird stuff like this going on where the bearing block is hanging off the edge. There's going to be a fillet in here which will end up filling this in. There is actually a radius on the bearing block, which I'm going to go ahead and model, and it's 1/8 of an inch if I remember correctly. So we just want to make this probably a little bit bigger just to kind of try to cover this. I mean, this really doesn't matter, but just visually I don't like it, so we're going to make this 1 1/8 inches. I think that looks good. That'll look pretty good. Alright, so let's that's really more of a visual choice. You want to support the face of the bearing block for structural rigidity, and you want these holes to be pretty far away from the edge, but really the size is really more just a visual thing because I want some blue on the outside of the yellow bearing block. If you're super close on weight, you should probably throw concerns like that out the window, but in this case, I want it to look nice. Alright, so let's connect a construction line from here to the circle, and then make this top line here parallel to it, and then this bottom line is parallel to this line, and this line is parallel to that line, so we know all three are parallel to each other. Now, let's make this. We're gonna want to go bigger than this. So we're gonna go. Oops, that was not right. 3/16, so that the full width of this is 3/8. This looks a little weird. I kind of want to angle this down and more aim for this corner rather than this corner. So let's actually do that. So let's we're going to keep the point, we're going to keep the line, we're just going to reattach it here. Actually, we're going to just delete this point. So make sure you select the point but not the line. Can I not do that? Okay, I guess I have to delete the constraints. So if I click on the point and then I look for which coincident constraint is, I want to delete the coincident constraints that are to the top and the side, but not that line there that's highlighted. So I need to delete this one. So when I'm deleting these, I'm left clicking, then right clicking, then clicking delete. Alright, so now I can move this, and you see how it's moving my lightning pattern. So I'm going to put it right about there. I still don't like the way that looks. Let's do something different. So let's connect a construction line across there and then connect that to that. So this is connected, and then let's make this perpendicular. That looks better. That looks a lot better. Okay. Next, let's dimension that to there, and let's make this big. Let's make that about 1/4 inch, so that web is a 1/2 inch wide, because the weight of the, I mean, that's going to bear, you know, the weight of the robot, essentially. We can make it even wider than that, but we'll see what that looks like. All right, so next, we need to repeat this, and we need to do a truss up to this middle web, and then kind of close that off. So let's create, turn off construction geometry, create an arc here, create, oops, a line up and back down, and then connect back to here. And we want this to be horizontal and that to be vertical. All right, so we want this to be in line with that, so let's place a collinear constraint. Then let's go ahead and make that. And like I said, I'm trying to avoid these dotted lines, but you can't do it entirely. So press enter, create a line across there, and then a line coming back like that, and press enter. Once again, avoiding the dotted lines if at all possible, because I want the least number of inferred constraints I can get. If you're doing a lot of this, you could go in and actually change your Inventor settings temporarily so that you don't actually have these lines. And actually, now that I think about it, I'm actually going to do exactly that. So I'm going to go to Options. I'm under the Constraints tab, and it's this point alignment one, so I'm going to turn that off. So now if I'm creating a line, no dotted lines at all, like none. Now if I hover over a point and then move away from it, now I have a dotted line, but that's because I hovered over the point, and that was what I wanted. And then as soon as I move away and come back, that dotted line is still there because I've hovered over that point and kind of told it that I want an alignment point. So I typically have point alignment on, but in this particular case, it's going to make it a lot easier if it's off. So let's connect these two with a coincident constraint, and then this line needs to be in line with that. So line those up. Then let's do the same thing here that we did here. So let's turn on construction geometry, create a construction line connecting those two. Then let's actually just connect this midpoint to one end of a line and then connect the other end of that line to the center point of the wheel. Then make those perpendicular. All right, so that will set these to be equidistant from each other, but now what we need to do is set these to be parallel. So we'll set that line to be parallel to the middle and that line to be parallel to the middle. Next, we need to have a vertical line in here somewhere that's halfway between these two wheels to kind of specify the center point of this web. So let's do that. Just a construction line, and then we'll just construct. We'll just a coincident constraint from the top of the construction line to that top line, and the bottom point of that construction line to the bottom line, just so it's even and it stays there. Okay, so let's actually, that was not a great way to do that. Let's actually delete this line. Like I said in an earlier video, this is the first time I've actually done this project. I've modeled drivetrains like this before, obviously, but the details of this one is actually new to me because I didn't model this whole thing completely before I recorded the video. So a little more of a following me along and how I would solve this problem kind of a thing than the videos normally are. Okay, so what I just did was I connected the two lines with a construction line, then I just placed a center point in the middle, and we'll just dimension to the center point. That's a cleaner way to do that. Okay, so let's make some equals constraints here between these arcs. That'll make this full circle kind of be what it's supposed to be. Next, let's dimension from here to here. Let's make this 1/4 inch as well, so it'll be wide like this. Let's make this here equal to that. And then this here is going to be, excuse me, 3/16. And then because we did this whole thing with the center point on this line, we don't actually have to dimension the other side. So that saves us the dimension. It looks all right. It looks a little weird. I think it'll look better once we get some fillets in there. But yeah, I like that. Okay, so next, let's do basically the same thing we did here, except here, mirror image. Now we can't actually mirror this, otherwise I would, because this wheel center is actually a little lower than this one, so the geometry will be slightly different, but we're pretty much just going to duplicate it. So we just need to create this shape and this shape here. So let's place our lines. Yep, press enter. And not having that point alignment on is super, super nice in this instance. I'm going to press enter and connect that line there and press enter. Okay, so now let's add our arcs. Connect there and there. And I'm going to coincident constraint those two and those two. All right, so now I want to line this up with the top, and then I want to do the same thing from the bottom. So I'm going to line those two up. I'm going to line those two up. Next, I need to create this kind of construction line T that's right here. So let's turn on construction geometry, connect those two corners with construction lines, find the center point, connect the center point to the middle with another line. Next, let's make those perpendicular. Whoops, I need to undo that. Let's click and drag this and get it closer to what it's supposed to be. Why is it doing that? Oh well, it's fine. Just drag it. I'll just drag it back to where it was. When you're placing, if you get something weird like that, where something flies out of place when you place a constraint, just undo it, drag the geometry manually, like really close to where it needs to be, and then replace the constraint. If Inventor has to move geometry a long way to get it to satisfy a constraint, it's probably not going to do what you want it to do. So just get it as close as you can get it, and then tweak it the last little bit using the actual constraint, and that'll lock it in place too. All right, so let's make these parallel. So parallel constraints there to the middle, and the other one to the middle. Let's make this arc equal to this arc, and then we'll make that arc equal to that arc, which is good. All right, so now we just got to go through and we got to dimension stuff. So dimension tool, from here to the center point will also be 1/4 of an inch. This to there will be 3/16, and I could make this dimension equal to that dimension. I'm just not, for the sake of cleanliness. This one here will be 1/4 as well. Oops. Alrighty, so that's pretty much it. So let's finish the sketch. Let's give this a save real quick. Let's do, it's got to be a cut. It's not an extrude, it's a cut. And then we just go through, pick all the regions, and click OK. That looks pretty good to me. We're going to do larger radiuses than we did on the gearbox. We're going to try to do 1/4 inch radiuses and see what they look like. I'll show you these are really sharp angles. I'll show you what happens when you do those. So let's do a corner around, and let's just go through 1/4 inch by default. So that's great. Go through and just click all these corners. If you pick a corner that you didn't mean to, you can always, once again, hold the control key and click on that corner again, and it'll remove it from the selection list. So basically, Inventor is going to fill this whole region in just to be able to get a fillet in here, and a corner around in there, and we might not want that, so we might go back, remove these two corners, and make those a smaller radius. I forgot that corner there. It's easier to forget corners, so just kind of check over and make sure you got all of them, and then click OK. So you see how it filled this whole thing in just to get this radius to be 1/4 inch. In some cases, that might be what you want. Like structurally, that's a fairly good thing to do. That being said, it looks really weird. So let's edit the corner around. Just double click on it, and let's click on where it says 24 selected. Hold Control, and I'm going to deselect those two. And then I'm going to just click it, click OK. Then I'm gonna go back and add another corner round feature to do these two, and I'll make these, select both of them, and I'll do 1/8 of an inch maybe. Alright, so smaller radius, so it doesn't fill it in as much, but that looks a lot better, and as long as that radius is not super tiny, 1/8 of an inch is not tiny, this really isn't going to take any strength out from what it was before. So I like that better. It looks a lot better. You kind of have this kind of like roughly round, like kind of column shaped structure going on. It just looks nicer. So that's great. So let's mirror this to the other side. We should be able to use the YZ plane. So if we select, well, where is it? Mirror. We got to click on our features. You can click on them in the browser or here in the viewport. So I'm going to click on cut one and then the 2 radius features that we created, the round corner round features. Then I'm going to click the mirror plane, click the YZ plane over in the browser. It shows the preview, click OK. And there's our part. It looks pretty good. So let's kind of do what we did before. Well, let's give this a save. Let's go ahead and change the color to blue. And then I want to check the weight and see how much weight we ended up getting out of this. So, come on. 1.26. I think we got about a pound out. So let's select all of those and suppress the lightning features. Then go back to iProperties here. Update. Oh no, we didn't. So we got we got 1.884 minus 1.26. We got about 5/8 of a pound out. What was that? 10 ounces. And so we have a reduction of 1.26 divided by 1.884. So a 33% weight reduction. That's not bad. I said about a quarter. I think I said 25 in the 25% in the last video was what I was expecting. So we did pretty good. This is once again a very aggressive lightning pattern, but depending on the game, especially with this being if this was 16th inch material, I would not lighten this nearly as aggressively. Actually, probably wouldn't lighten it much at all. Definitely not this aggressively, unless it was a really a game where there was a lot more fine maneuvering and not a lot of open spaces for people to get up to high speeds where they can run into you at a high speed. Then I might be okay lightening more aggressively. Okay, well, actually, let's close this out. So we're going to do a very, very similar pattern on the inside drive rails. Actually, this part here and this part here will be identical. The only differences are going to be around the center wheel because we've got to deal with these 4 holes. So really, when we do this, we're going to repeat a lot of this, which is going to be kind of obnoxious, but it's just what we have to do. So, yeah. All right. Let's open up our middle drive rail here. We're just going to kind of start over. I'm going to go a lot faster on this one because we've done it once. You're just going to repeat the same thing. So let's start sketch. Let's go through and project our geometry. We really only need these 3 edges. I projected this edge over here, the last one, but I really didn't need that. There's kind of 2 edges here, so I just projected the inside of this notch, but we're just using it for alignment, so we don't need it to extend all the way across, so don't worry about it. Then we're just going to project these 2 circles. We don't need this one, obviously. We need these 2 holes. We don't need these little holes because we're just kind of surrounding those with the circle. We're not really worried about where the hole actually is. Okay, so let's turn off construction geometry here. Let's create our lines. Press enter. Press enter. I'm not placing the arcs just yet. Press enter. Yep, press enter. I'm just going to go through and do a bunch. Press enter. So you notice there was a lot of points that were lining up. Like that point alignment caused these 2 lines to be attached, which is not what I would have wanted. I would have wanted to use as a collinear constraint, but this is okay because that's what I was going to do anyway, so I'm just going to let it slide. But basically, every end point of the line that I was placing while the line tool was active, Inventor will automatically do point alignment, even though I have a point alignment turned off. So if you don't want it to align to those, I just escaped out of the line tool, and then I go back into the line tool, and now I'm not getting a bunch of dotted lines anymore, so I can kind of keep working without having to deal with that. Okay, so all right, so that's my line. My lines. Let's create my arcs. Attach each one at one end and leave the other end open, just so I can do it with a coincident constraint. That just placed an equals constraint. What did that equal? Oh, that one. Yeah, that's fine. I was going to have to make those equal somehow anyways. All right, now let's do coincident constraints and connect all these. All right, so now let's do a bunch of construction lines. So I've got to connect these two wheels so I can get the center point in the middle. I've got to do that line, and I've got to do the line from the center point of that line to the center point of the wheel, and then I've got to do the same thing here. Alright, so let's kind of line these up, get them closer to where they're actually supposed to be, place the perpendicular constraints. Let's place the equals constraints on these arcs. And this should already be, yeah, because there was an equals constraint there to there automatically that I didn't place. Okay, so next let's do parallel constraints from there to there, and there to there, and the same thing over here, there to there, and there to there. And I might have to bounce back to my original, the outside drive rail to if I don't remember what these dimensions were, but I think I remember all of them. But it's okay to go and measure. All right, so let's start placing dimensions. Actually, no, we got to get our center point in here. Yeah, okay. So dimensions. So everything's going to be a 1/2 inch from the outside edge. Let's get that going. All right, next I'm going to need a collinear constraint here. So collinear constraint there to there to line that up. Let's dimension the radius of this, which is 1.125, and we know that this was 0.18. Come on, keep hitting the 7 key. Then this was also 3/16, 1.875. That to that was 1/4 inch. This was also, whoops, dimension. This was also the same. This was 1/4 inch as well. Alright, so that's that. That's done. I'm going to exit the sketch, save, and then go back into the sketch again just because I did a lot of work there, and if my computer power is off or something right now, I don't want to have to redo it. Although if my computer power is off right now, I'd probably end up re-recording the video or something because I don't know if it would save. Alright, anyways. So, now we've got to deal with this. I think the best way to do this is to connect. Basically, we're not going to have a vertical web, so like we've got this vertical web here. I don't think we're going to do that here. I think we're going to actually, no, I still want the vertical web. So I think we're going to have the vertical web. We're going to have a web from this center point to this hole. We'll have the bottom here to deal with this hole. Then we're going to connect these two with the vertical web, and then this kind of angled web where it was aiming at the center of this bearing block before, we'll just aim that down to this hole here. So we'll kind of have like triangle here, and then we'll have kind of a weird shape here, a weird triangle here, and then mirror it on the other side. So let's, if that doesn't make sense, I'm kind of, like I said, I'm doing this live. I haven't thought this through ahead of time, so I'm just kind of winging it. In addition, because we've got standoffs on here, let's create some 3/8 circles. We'll make sure that these landings are big and fat because we really want them to be wide enough. We probably want them to be wider than the standoffs actually. So we might increase the circle size just to make sure there's extra room. All right, let's place some arcs here and here, and these are already in the way. So I'm going to move those into the middle. Alrighty, so we know we're going to have a line there. We're going to have a line there, and there. I don't know what we're going to do here yet. We're going to have a line there. And actually, I'm going to delete that line. Let's connect that to that. Let's connect these two with a line. And then from here to here, actually, no. We're going to have a line there that's a construction line, and the center point of that line is going to be connected to that. So we're going to end up with kind of some weird geometry here. So let's make this... Let's actually, I'm going to get rid of... Actually, no, I'm not going to do that. Stop. Calm down, Orion. Okay. We want a larger like landing on here than actually the 3/8. So this is the diameter of the stand up. We're going to make sure there's a circle of material around that that's bigger. Okay, so let's start. Oops, I didn't mean to do that. Sketch. Go back to the sketch. Okay. Line. Let's create this triangle here because this will help us nail some of this stuff down. All right, we need to create a perpendicular constraint here to here. We need to create a parallel constraint here to here. Whoops. Drag that closer where it needs to be. Parallel constraint. Better. Okay. So now, create a collinear constraint between these bottom two. And we know that these corners are going to be even, so I'm just going to create a construction line because I don't actually have this line up here yet to create a what's it called? Collinear constraint. Alright, so we'll dimension this here shortly. Actually, we can dimension that now. Yeah, and we'll deal with this here in a bit. Alright, so now what we're going to do is we're going to create an arc here. I think that's the best way to handle that. And then I think we don't need an arc here because the fillet will fill this in and it'll be bigger than the arc anyways. Same here. When we add a fillet to this, there'll be enough meat in between here that we don't need to worry about actually creating an arc. Out of the arc tool line. Alright, connect those two, connect to those, and then come back up to here. Alright, I want this to be horizontal, and we want that to be vertical. So horizontal constraint on that, vertical constraint on that. Parallel constraint between those two. So now we can go ahead and dimension that to be 3/16. Okay, that locks all that down. I think from here to here we're also going to want 3/16. And basically we just got to pick a radius. We can only go that small because otherwise then it separates. I don't know what this is though. Let's create a fillet between here. Now normally I want to do my corner rounds outside of the sketch, but in some cases where I have like geometry that won't work right, if I don't put a fillet in, I need to put the fillet in. So let's go to the fillet tool. 1/8 of an inch is fine. Actually, I want that to be 1/4 of an inch. All right, so now we have a lot more freedom to kind of make this whatever size we want. So let's pick a radius here. That's still too big. Let's do 3/8. Oh, that's too small. Oh, I see. Can I not? Oh, I can't go any smaller than that. Why can't I go any smaller than that? Oh, right. I've got this point here that's still connecting us to this line. Right. I can delete that though. All right, I should be able to do it now. Yeah. Okay. Now I can do 3/8. Okay, that's good. And then there'll be a little fillet in here to smooth that out. It looks a little weird, but it'll be okay. All right. So next, I need to make that collinear with that, and then I am actually going to need an arc here, and that's really why I was waiting on this, because I wasn't sure if I was going to need that arc or not, but I do. So we'll create an arc there, then we can patch that back in, we'll make that vertical, we will make, well actually let's just make that equal to the 3/8 one. And then once we get a fillet in here, it'll fill this in, and so this won't look more complete. All right, now let's dimension between there and make that equal to that. Let's make these lines parallel here. Let's make these two arcs equal to each other, and then make that arc equal to that arc there. This is going to get tight, but I think we'll be okay. Alright, so we're going to need an arc here, and we're probably going to have to do this fillet thing again. So let's do that. Yeah, that's kind of what I figured. This is not going to let us. Oh, it actually. Oh, right, because we haven't dimensioned this yet. So let's put the fillet up here, and this will also be 1/4 of an inch, and then we can make this equal to that. Oh, it doesn't like that. Oh, right, because I got to delete this point again. For those of you watching that video, you've got to delete that little like ghost point up in the corner, otherwise you're going to have errors. Alright, so these are all parallel, so let's go ahead and make these 3/16 of an inch. I just made those two dimensions equal to each other. And then we'll do our customary 1/4 inch on this. Alrighty, that looks weird. This is such a small amount of space that I might consider just not doing this lightning hole. But I think the whole thing is going to look a lot nicer if we do, so I think we'll leave it. We'll see what it looks like when we add fillets, otherwise we might come in and not extrude this. You can always add pockets and then not cut them. Like just not, you can put them in the sketch and then not actually have them in the final part. That way if later you want to go back and turn them back on or turn them off, you can always do that. So let's finish the sketch. Let's cut, not corner seam, cut all of these out. Doesn't look too bad. Alright, so let's corner round this. Let's do, why is this point, this should be 0.25. I'm going to go back and click on 4 selected. Click on all these. We know that this was too sharp. We ended up doing 1/8 of an inch there. I don't know. I'm not going to do that one either, so I'm going to hold Control and click on that line again. I'm probably going to do the same here, actually. So I'm going to deselect that one. That's got to be 1/4 inch. That's got to be 1/4 inch. That's got to be 1/4 inch. This is going to look really bad. So I'm going to actually deselect all of those. I'm going to do all 1/8 inch radiuses in there. These can all be 1/4 though. Alright. Oops, I forgot one. So I can go back to corner round, click on 22 selected, and pick that one again. That looks good. Is that the same? Yeah, it looks the same. Okay. Now let's go to corner round, and we're just going to pick just those two, make those 1/8. Looks good enough to me. Alright, so let's go to corner round. Oops. Pick these. And then we'll make those 1/8 as well. Click OK. Oh, I meant to do this one. Actually, we need to lump this one in with these two. So let's going to be this one here. Click on 2 selected. Looks okay. This still looks a little funky, but I mean, it looks kind of cool. But you can play with this. You can play with radiuses. You can play with exactly how this is done, and make it look better if you want. But this really looks fine to me. So strength is more important. Basically, strength is the most important thing. Weight reduction is the second most important thing, and looks are the third most important thing. So you want to make sure it's strong. You want to make sure you get weight out before you worry about the other two things. All right, so let's mirror all of this. So you can actually select the features before you create it. So I can just click on cut, hold shift, and click on the bottom, just select all 4 of those. You could also hold Control and click on each one. But either way, mirror. And then I can just click on mirror plane, expand the origin, mirror like that. And there we go. Alrighty, I'm happy with that. I like the way that looks. This looks a lot better when it's mirrored. It looks pretty cool. Let's give that a save. I'm pretty comfortable with how strong that is. This is... Yeah, okay, so let's color this blue. Go back to our assembly. Update our assembly. Up the top. Now you'll notice that the mirrored parts, even though they're updated so they have the holes, their coloring doesn't change. You kind of have to do the same kind of a deal with these as you do with imported components, where you have to go in. Let's right click on this and open it. You have to go to solid bodies. Oh right, it doesn't actually, I have to color this individually, so the color doesn't get inherited from the other part. So I have to color this blue, and then I have to do my solid bodies thing. I have to clear the overrides, go to properties, clear overrides as part, and then it'll be able to be colored. So I have to do this out one. So I'm going to left click on the part, then right click on the part, open, go to solid bodies, right click on solid one, go to properties, clear all overrides. As part should already be selected. If it's a mirrored part, then I can select my color that I want. It's color blue. Give it a save, close it. Alrighty, that is our final drivetrain for this video. If enough people want me to do the fasteners, I suppose I'll do the fasteners, but I'm not planning on doing the fasteners at this time. If you model this, I would encourage you should try to put a battery in this. You should try to put all the electronics in that. If you don't know what the electronic components are, you can contact me and I'll kind of give you some help. But yeah, the next step typically in drivetrain design you'd need to have a battery box, and you would need to have mounting holes for all your electronics. Put the electronics in the assembly, and then lighten the belly pan. And typically we just do kind of a truss pattern in the belly pan, just with really generic shapes. You don't have to get crazy with it, because otherwise you'll spend a lot of time lightening this whole huge thing. Alright, so that's that. Let's look at the weight real quick, and I'll briefly talk about fasteners, and then we'll end it. I'm sure this video is also really long. I know the last one was. Alright, so about 28 3/4 pounds. That's pretty good. If the drive rails weren't 1/8 of an inch, you could save some weight there. You could do less lightening, but make the material thinner, and you would actually save weight overall. We're probably going to try to do drive rails next year that are 1/16 again, and use studs instead of the fastener, instead of tapping the aluminum here like we are. Okay, so fasteners. Typically from the outside of this to the other side of the aluminum is just under 1/2 an inch. So typically we just use 1/2 inch fasteners, and the space in here is enough that the screw sticking through slightly isn't a problem. We just use socket heads on all the bearing blocks. So we do all the bearing blocks the same way. You would need long socket heads, long enough to go from the outside here to the other side, and then you'd need another 1/4 inch-ish. So you wouldn't want to use 1 3/4. You'd want to use 1 7/8, but I don't know if you can get them, so you'd probably be okay with 2 inches. I think that motors are tapped like 1/2 an inch deep, so you'd probably want to use like 2-inch fasteners, socket heads, 1032s. Obviously, I think those are the only screws actually on this whole thing, because the shafts don't have screws in them because the shoulders hold them in place. Obviously rivets, but we don't put rivets in the CAD model. The only other thing would be spacers. So typically what we do is for small spaces like this, I believe this is a 1/4 inch, we just use those hex ones that Vex has. Those are easy to assemble because you don't have when you're putting this together, you don't have the bearing blocks on there. So you slide the shaft in, you slide the spacer in from the end, then you put the bearing block on and put the 4 screws in. For longer gaps, you can use Vex's spacers if you want. However, typically on Stellar Robotics, we just cut a piece of PVC and we slide it over. I believe it's oh, now I don't remember. I think it's 1/2-inch PVC that fits pretty well. It's kind of loose and it rattles around a little bit, but we've cut them a little narrower. It's okay if the wheels wobble back and forth slightly. I mean, it's just this is a pretty inexact science. In here, you've got to actually have a spacer that rests on the bearing. We'd probably do a piece of PVC, although I'd be tempted to try to just fill that with the VEX spacers, but we'd probably do a piece of PVC because it's a fairly large gap. Alrighty, thank you for watching. This is probably our last video unless everybody convinces me to do a fastener one, but thanks for watching.